things that you absolutely 100% must know for your exam that's on fractions. So just a reminder, your exam is next Monday, period 5. That's the non-calculator section. Fractions is in the non-calculator section, that's why we're doing it first. Friday, you're allowed to use a calculator, and that one is on data analysis, and I think it's got a bit of something else in there, but I'll have to double check. So the 3 topics are fractions, decimals, and data analysis. As far as I can remember, the first 2 are non-calculator, the last one is calculator. Okay, so the important things to know about fractions, the things that we've already learned, are you need to know how to simplify fractions. So you need to be able to put things in their simplest form. You need to know what an improper fraction is and what a mixed numeral fraction is, and you need to be able to convert between the two. You need to be able to add and subtract fractions. You need to be able to multiply fractions, divide fractions, and then what to do when you come up, when you're given a whole number and have to, I don't know, add it to a fraction or whatever. All right, here on the board, I have 4 different fractions that are not in their simplest form. What does simplest form mean? Leah? Yeah, awesome. Mark, what are your thoughts?
It's not the smallest amount it can be.
Yeah, awesome. These numbers could get smaller. So what I need to do is I need to find a number that will go into the top and into the bottom. So with that first one, 3 over 6. Are there any numbers that you can think of that go into both 3 and 6? Mark your hand up first.
1 over 2, which is off.
Awesome, you get the step ahead, but fantastic. So what number goes into 3 and 6? Sandy? 3. Not quite, 3. Awesome. So what I'm going to do is find out how many 3's go into the top number and do the same to the bottom. So I'm dividing the top by 3, and then I'm going to divide the bottom number by 3. So how many 3's go in 3? 1. How many 3's go into 6? 2. Cool. Alright, the same with the next one. I want to find out if there are any numbers that fit into the top number and the bottom number. Janessa? 5. So I'm going to divide the top by 5, and then I'm going to do the same to the bottom. So how many 5's fit into 5? Yes? 1. And how many 5's fit into 10? 2. Cool. Alright, let's do one down here. Are there any numbers that go into 12 and 36? Dia?
12.
Great. How many 12's fit in 12?
4.
1.
4.
And what am I going to do to the bottom?
Divided by 5.
Divide by 12. So, how many 12's fit in 36?
3. 5.
6.
4. 3.
3 12's are 36. So, 3. So, this one is equal to 1 over 3. Mark, you had a question?
Yeah. Miss, you see how you're doing that strategy where like you divide the first number by its like.
Yep.
Miss, is that always going to be like the same for each like for every fraction?
As in that method, as in finding a number and dividing the top and the bottom?
Yeah, miss, because you see how like, the first one is like 3 and you divided it by 3?
Yep.
And the other one is like 5 and you divided it by 5?
Good question. You know what? Let me come up with another example where it'll be a different number. Let's go 8 and 20. Alright. Okay. To answer that question, let's give this one a go. What number goes into 8 and 20? Mona, your hand went up first.
2 4's go into 8.
Great, so 4. So, we're going to divide the top by 4, then we're going to divide the bottom by 4.
2.
So, how many 4's go into 8? 2.
5.
How many 4's go into 20? 5. Awesome. So it's not always the number that's on the top, you just have to think about what number it might be. Now, a good trick, if you ever get a question like this and you don't know your 12 times tables, just divide by 2 over and over and over again until you can't divide any. So sometimes, thanks everyone, sometimes you'll come across fractions where, the answers are a bit outside of the scope of your times tables. I'm not expecting you to know how many 6's go into 102. So we need to know a different way to do that. So if the number on top and the number on the bottom are both even, What does even mean?
It's the same. The same they can divide by 2.
Yeah, awesome. So if it ends in a 0, a 2, a 4, a 6, or an 8, it means it's even. What number can all even numbers be divided by?
2.
2. Fantastic. That's what makes them even. So if you don't know what number might go into this, you don't know how many 6s will fit in here or whatever, but they're both even, you can always divide by 2. And keep going until you get the smallest number. Alright, so let's divide by 2. Divide by 2. Divide by 2. So, 6 divided by 2 is? 3. 102 divided by 2?
151.
51. Cool. So when you divide anything by 2, what you're doing is you're halving that number. So, this will actually divide further. You know what? Let me come up with an answer that won't. Sorry. I'll stop.
5. 3.
There we go. Alright, sorry. So that will make this number 3. Now, this won't actually divide any further because neither of those numbers are even. And 3 won't go into this bottom number. So that is as small as that fraction can get. But this one down here, 12 doesn't fit into 40. So what can I do here, since the bottom and the top are even numbers, what can I divide them by to find out if they can go any further? Mark your hand went up.
Miss 6.
Ooh, yes, but if I didn't know my 6 times tables, if I couldn't think, what would go into that?
3.
Yes, but if I didn't know my times tables and I know they're both even, I can just do 2.
Yes.
Awesome. Alright, so how many 2s fit into 12?
6.
6. How many 2s fit into 40? 20. Alright. My top and my bottom are both even still. So what does that mean as far as continuing?
You can simplify it one more time.
I can simplify it one more time. Why?
Because it's 2 even numbers.
Awesome. If your number on the top, if your number on the top and the number on the bottom are even, it means you've got to keep going. It's not in its simplest form. You've got to wait till you get at least one number that's odd. So we're going to divide again by 2. Until we get some numbers that can't be divided by 2 anymore. So 6 divided by 2 is?
3.
20 divided by 2 is? 10.
That's
Now, can these be divided by 2 anymore? No, they cannot. Cool. So if ever you're stuck and you can't think about, you know, you're in an exam and the pressure's high and you can't remember your times tables, when in doubt, divide by 2. Just keep on going until you get a number that they can't be divided by 2 anymore.
Are we going to be able to use a calculator?
No, the first exam is calculator free. Therefore, it's helpful to know that if you get stuck and you can't think of what numbers might go in, just divide by 2. Keep on dividing by 2. Next up, we want to be able to turn improper fractions to mixed numeral fractions. Now, what's an improper fraction? Yes? Yeah, cool. They're improper because the number on top is too big. I love improper fractions personally, but some people don't. And they're called improper because the number on the top is too big for the number on the bottom. Yes, Mark?
Miss, can I have a go with the first one?
Yeah, great.
Miss 11 fits into 5 2 times because, and then Miss the extra one will become like you carry it. So like Miss, I don't know the name of it, but like you put it on the side.
Your remainder?
Yeah.
Yeah, awesome. Well done. So what we want to do, as Mark fantastically said, we want to find out how many of the number on the bottom fit into the number on the top. So in this case, how many 5s fit into 11? 2. Great. So I'm going to put a big 2. But I've got some left over. How many do I have left over? 1. So So I put a little 1 because that's my remainder. And whatever my denominator is what I put underneath my remainder. Did I do that too fast?
No.
No?
You did it very nice, miss.
Oh, thanks, Daniel. Alright, now here. I want to see how many times the number on the bottom fits into the number on the top. Is your hand up? No? Anyone over this side feeling brave?
Me.
Marina.
4.
Great. It goes in 4 times because 3 times 4 is 12. So how many's left over?
2. It's 2.
Great, it's 2. So where am I putting my 2? Am I drawing a big 2?
No.
No, what am I going to do, Shaka? Awesome, and I'm putting it over 3 because 3 is my denominator. Awesome. Alright, same dealio with this one. Eric, you feeling brave? How many 2's go into 9? How many 2's fit into 9?
4. Why told him the answer, miss? I saw your hands.
And how many's left over?
1.
Awesome. And what do I put it over?
2. 2.
Awesome. Sorry to put you on the spot there. Alright, and then lastly, Dow.
Yes.
What am I going to do here with this last one? I want to find out how many of the number on the bottom fit into the number on the top. How many 6's fit into 17?
3 or 4.
Ooh, too high. Go down a little.
2.
Awesome. So, 2 6's are 12. So how many's left over?
1. 5.
5. Over.
6.
Awesome. Any questions about that? No? Cool, I'll give you a second to copy that down. Okay, now we want to do it in reverse. I want to turn these mixed numeral fractions into improper fractions. So at the end of the day, my number on the top is going to be bigger than the number on the bottom. And I'm not going to have any of these big whole numbers anywhere. Alright, so what I want to do is I want to multiply my big number with my denominator, okay? So I'm going to multiply these two together. So 2 times 6 is 12, and then I want to add the one on top. Can you see this texture? And then we do it in colour. So first, I multiply these, and then I add this one. Okay? So 2 times 6 is 12, plus 1 equals 13. And what am I going to put it over?
6.
Yeah, great. I put it over whatever my denominator is. Hang on, let me get a different colour so you can see it better. Let's do black. So 13 over 6. Now these are a bit challenging, I'll admit. So first I multiply these two together, this one and this one, and then I add the one on the top. Okay?
I'm getting
Awesome.
It's so cool.
So you want the aircon off?
No. Can I put my doctor, please?
Yeah, of course.
Have you seen it?
So 4 times 5 is 20 plus 3.
23.
So it's going to be 23. And what am I putting it over?
5.
I'm
5.
going where you go.
And why 5?
Because that's the best one.
Great. I put it over my denominator. I feel like I have a couple of people not paying attention.
Miss, I'm paying Miss, is it okay?
Okay. But if Miss Gale or someone walks in, you take it off quick. And I never said you could. And even though it's on camera, I never said you could. Get that bit out. Okay. So I'm going to multiply these two numbers together. Then I'm going to add the one on top. So 1 times 8, 8 plus 4.
12.
And what am I putting it over?
8.
Awesome.
Miss,
So I'm not going to draw my instructions on this
Since
one.
you're friends with me, and I'm friends with the people that
Sharper.
go to school. You wanna see something?
Oh, Cool. So first I'm multiplying, so 10 times 3 is?
Do you have the class with the 30%?
Great.
There's around 7
Awesome.
people behind it.
Over.
Three.
Fantastic. Next up, we have probably the most difficult, probably the most difficult point. The ones at the top are easy, but the ones on the bottom are a lot more complicated. And if you can wrap your head around what we do for adding and subtracting, you will be fine with this test, because this is definitely the hardest point for sure. All the others are super easy by comparison. Yep. In my opinion, this is the hardest. Absolutely. By a large margin. Alright. Now, when they have the same denominator, we don't have to do anything, we can add them or we can subtract them. It makes it super easy. But when they don't have the same denominator, that's when things get sad. So here, here they have the same denominator, so I can go ahead and add them without having to worry. So 4 plus 1 is? 5. So if I have 4/5 and 1/5, how many fifths will I have? 5 over 5, yeah, cool. So my denominator stays the same. Now I've got 5 over 5, and can I simplify that anymore? Great, into what? 1 whole. Yeah, cool. So if I've got 5 over 5, that's 1 whole. Any questions about that so far? No? If you're adding fractions with the same denominator, it's super easy. You just add the numbers on the top, and that's it. Good question. That's what we're going to get to on the next row. Here, we're subtracting fractions with the same denominator. So, can I do it if they've got the same denominator?
Yes.
Yes, I can. So 7 minus 2 is? 5. And what will it be over? 8. Awesome. Very easy.
Wouldn't it be 0?
You don't subtract the denominators, and you don't add the denominators. The denominator stays the same. Now, this is where it gets complicated. Now, I strongly recommend that everyone pays attention to this one, because this is the most complicated part for sure. These have different denominators. I can't add them because they've got different denominators. I need to turn them into fractions that have the same denominator. So, can you think of any number that 3 and 6 both fit into?
6.
Awesome. 3 and 6 both fit into 6. So I want them both to have a denominator of 6. What do I have to do to 3 to turn it into a 6?
Times 2.
I'm going to times it by 2. So if I do that to the bottom, I also have to do that to the top. So I've multiplied this entire fraction by 2. So 1 times 2 is? 2. Cool. Now this fraction has turned into this. So 1 over 3 has turned into 2 over 6. My second fraction is already out of 6, so I don't actually have to do anything to that. I just bring it straight down. Now can I add them?
Yes.
Yes. Why?
Because they have the same.
They have the same denominator. So 2 plus 4 is?
6.
Over 6.
With 1 whole.
Yeah, which I could also simplify into 1. Cool. Now let's do a more complicated one. And this is as hard as it gets. This one, I only had to multiply, I only had to double one of my fractions. The other one stayed the same. Here, I can't do that. I'm going to have to change both denominators. Gentlemen, are you right? Here I'm going to have to change both fractions to make them fit into something else. So what number can 3 and 10 fit into?
30.
30. Awesome. Well, how did you come up with that number?
It's because 3 goes into 30 and 10 goes into.
Yeah, cool. If you multiply them together, you're bound to get a number that they'll both go into. So, 10 times 3 gives us 30. So, I want them both to be over 30. So, what do I have to do to 10? Shh. What do I have to do to 10 to turn it into 30? Great. I'm timesing it by 3, and what I'm doing to the bottom, I also have to do to the top. So 2 times 3 is 6. Oh, 6. And 10 times 3 gives us 30. Cool. So I've turned that fraction into something over 30. Now I'm going to do the same to the other one. How do I turn a 3 into a 30? Ah,
Times it by 10.
great. Times it by 10. So what I do to the bottom, I also have to do to the top. So 1 times 10 is 10. Now can I add them?
Yes.
Yeah, cool, I can. Why? Fantastic. They have the same denominator now, so I can add them. So 6 plus 10 is 16 over 30. Can I simplify this any further? Yes, I can. They're both even numbers, which means that I can do what to them? Divide them by 2. So, how many 2s fit in 16? 8. Equals 8. How many 2s fit in 30? 15. There we go. Not only did we turn them into numbers with the same denominator, but then we simplified as far as we could. Right, now I want to do the same thing. I want to be subtracting, but I can't do that yet, and why not? Why, Daniel? Why can I not do that besides my lack of motivation? What's wrong with this question?
Because the bottom number is
Awesome. The bottom numbers aren't the same. So I need to change them to numbers. I need to change the fractions to ones that have the same denominator. So, any ideas as to what number 5 and 3 can go into? Since 3 doesn't go into 5, yeah, Mark?
Miss, I have a question.
Yeah.
Miss, why can't you just take away 2 from the 5?
Miss, that'll work.
Well, I don't think that'll work. It might, I don't know.
Miss, take 1, put it in the 3, and then, yeah. Miss,
Yeah, it probably wouldn't get the right answer.
Miss,
I don't imagine.
1.5, miss.
Alright, I'm loving all these hands up, but if ever you come across numbers that don't go into each other, thank you, Year 7, just multiply them together. So Dia, 5 times 3 is, cool, so I want to turn them into numbers that have denominators of 15, and I'm subtracting. So, now, what do I have to do to a 5 to turn it into a 15? I'm going to times it by 3. So what I do to the bottom, I also have to do to the top. So 4 times 3 is 12. So this fraction has just been turned into 12 over 15. Now, what do I have to do to a 3 to turn it into a 15?
Miss, why
Sorry, I heard a question. And what do I have to do to the 1? Times 5.
5.
Alright, so 1 times 5 is 5. Now, can I subtract one fraction from the other?
Yes.
Yeah, cool, I can. So, 12 minus 5 is?
7.
Over 15. Can't simplify any further, they're not even. So that's how I leave them. Alright, let's do the next one. 2 doesn't go into 9. So what denominator can I come up with for these bottom numbers? Sandy. Awesome. I'm going to give them a denominator of 18. And the reason for that is because I just multiplied these two together. So 9 times 2 gives you 18. So, what do I have to do to a 9 to turn it into an 18? 10. Times it by 2. What I do to the bottom, I also have to do. 7 times 2 is?
14.
Okay, what am I doing to a 2 to turn it into an 18?
Times 9.
Great, what I do to the bottom, I also have to do to the top. So, 1 times 9 is? 9. Can I subtract this one from this one now?
Yes.
I can. So, 14 take away 9.
5.
Over.
8.
Can I simplify that?
No.
No, I cannot. Okay, let's take 2. Now we're going to be multiplying fractions. This part is super duper easy. Way easier than adding, way easier than subtracting. In fact, I'm going to go out on a limb here and say I love multiplying fractions. Super easy. So all you have to do is multiply across, and that's it. So I'm going to be multiplying. So when you're doing these, you ignore the bottom and you multiply the top. Then you ignore the top and you multiply the bottom. All right. So 1 times 4 is 4. All right. Now I'm going to ignore the top. 3 times 5 is 15. And that's it. So when you're multiplying, you multiply across. You multiply the numerators, then you multiply the denominators, and you're all done.
What do we have after this?
If you can simplify, you should. But this here can't be simplified. Alright. So I'm going to multiply my numerators. So 1 times 7 is? 9 times 9 is?
81.
That's 81. Thank you.
Can I do this?
You know what? Yeah. Okay. So I'm multiplying my numerators first. So down, what do I get first?
18.
Awesome.
And then this other one is 40.
Fantastic. But first, what do you notice about that answer?
It's
Michigan.
I'm Michigan.
You can simplify. Beautiful. Because the number on the top and the number on the bottom are even, it means the number 2 will divide in. So, generally, if you can simplify, you should. So, I'm going to divide the top and the bottom by what?
2.
2. Divide by 2. Divide by 2. How many 2s fit in 18? What's half of 18? 9. What's half of 40? 20. I can't simplify any further, so that's it. Alright, and then lastly, I want to multiply. Oh, Christian's volunteered to answer this one. Sorry. Because this is the first one that Christian's volunteered to answer. Sorry, I'm going to have to go ahead and take advantage of this opportunity. Christian, what am I doing here?
Starting the top and the bottom.
Awesome. So, what number will I get on the top?
6.
Awesome. And what number will I get on the bottom?
28.
Great. What can I do with this answer though?
You
Yes.
have to divide by 2. What?
I have to? Down? Tell me.
She could do.
That's alright. I'm ignoring everyone else but you.
You have to divide it.
Why?
2.
Awesome. So, 6 divided by 2 gives me
3.
3. And 28 divided by 2 is 14. Great.
Split the number.
Now, alright, now we're up to dividing. Now dividing is very similar to multiplying, and you'll soon see why. Now, dividing has a little magic trick that I love. So this is our first fraction, and this is our second fraction. What I want to do is flip my second fraction upside down. So I'm going to write that somewhere. So I'm going to flip second fraction. So I'm going to flip this second fraction upside down, and then I'm going to multiply instead. So it turns into, the first one stays the same, but now I'm going to be multiplying my flipped second fraction. So what's this fraction going to be if it's flipped?
7/4.
Awesome.
Did she get her book back?
Yeah, 1 second.
So I'm going to explain that again one more time, because this is a magic trick in maths. So when you have to divide, take your second fraction and flip it upside down. And then instead of dividing, you're going to multiply. I'm going to say that again, because repetition is always good. When you're dividing, take your second fraction, Paolo, and you're going to flip it upside down. And then instead of dividing, I'm going to multiply. So that is something that you should absolutely memorize. When you're dividing, take your second fraction, flip it upside down, then multiply instead. So now, can I multiply these?
Yes.
Yeah, easy peasy. How do I do it? 2 times 7 is? 6 times 4 is? 24. Right. Any questions about that process? Yes. I can. Both of these numbers are even, so I can simplify. What am I going to divide by? Yes, if I can find a good colored text, so let's go this one. Divide by 2, divide by 2. 14 divided by 2 is? 24 divided by 2 is? Happy days. Alright, let's do our next one. Yeah, I'm just going to draw a line down here so you know what I'm doing. Alright, can anyone tell me what my magic trick is?
Yes.
Thank you for your enthusiasm, and I'm hoping someone who's been paying slightly less attention. Not saying you haven't been paying attention. Would you like to go? Awesome. So, I'm flipping my second fraction and it will become 8/5. My first fraction stays the same, and instead of dividing, Daniel, what am I going to do? Instead of dividing,
Divided.
instead of dividing,
Multiply.
cool. Alright. So, Michael, help me out here. How do I multiply these? Multiply my numerators for me. What's 1 times 8? Okay. What's 3 times 5? 15.
Is that it?
That's it. When you're dividing, you take your second fraction and flip it upside down.
Miss?
Yes.
Why did we have to divide it by 2?
Because it could be simplified further. So if ever you get an answer where the number on the top and the number on the bottom are even, divided by 2. Here, I don't have an even on the top and the bottom, so I'm just going to leave it.
But Miss, what
Yes.
if we get the bottom?
See, like here, this one's odd, this one's even. It means the bottom number can't be divided by 2, so I just leave it. So if ever you come out with an even on the top and an even on the bottom, divided by 2, but here the number on the bottom is not even, so I just stop. I don't have to simplify. I'm going to write some notes up here, so I'm going to flip, and then I'm going to multiply. The important things to remember are don't flip your first fraction. Don't ever flip your first fraction or you're going to come out with all kinds of sadness. Only flip your second fraction and then multiply. Okay. Alright, now comes our last dot point, which is very exciting. It's very important to know that all whole numbers are over 1. Alright, I want you to understand for all future maths reference that all whole numbers are over 1, and I'll show you why. If I have a fraction of 1 over 1, what is that going to be? How many whole numbers do I have?
0.
1.
Oh,
Because 1 goes into 1 one time.
yes.
If I have 5 over 1, how many times does 1 go into 5?
5.
5. So what this means is if I have 1 over 1, it's the same as writing just 1. If I have 5 over 1, it's the same as writing just 5. They're equal to each other. Any whole number can be written as itself over 1. Okay, I'm going to say that again. Any whole number that you could possibly think of, so whether it's 4, 7, 3, 2, 1, this number, if I was to write it as a fraction, would be what? This number over 1. Okay? Any whole number as a fraction is over 1. And this is important if ever you have to do multiplication or addition or whatever with fractions that are with whole numbers. Yes, Mark?
Miss, but 5 doesn't go into 1.
When you do division, when you do fractions, it's how many times does the bottom number fit into the top. So how many times does 1 go into 5?
5.
5. Alright, so here. Now I want to do multiplication. I want to multiply 2/3 times 1. Now, because I'm not a maths whiz, and I don't expect you guys to be maths whizzes, we need to convert this into a fraction so we can multiply them like we were practicing before. Thanks, Daniel. Don't pass notes. Thank you. Unless it says Mrs. Walters is amazing, no passing notes. Thank you. Okay. Shh, come on, we're on our last point. Last point, and then we're done. So, we want to be able to do this. We want to be able to multiply fractions. Year 7. Knock it off. We want to be able to multiply like we were doing before, where we multiply the numerators and then multiply the denominators.
Oh.
Beautiful flowers, by the way.
It's not even mine, miss.
Oh, good. So you're getting other people's stuff confiscated. Alright. But I can't do that because this one here doesn't have a denominator. So how can I give this one a denominator?
Miss, you do it over this one.
Jordan, what are your thoughts? Awesome. Anyone else know the answer to that question? Who
Yes.
was listening? Christian.
This question was
How can I turn this 1 into a fraction?
Miss Anna.
Miss,
You multiply it.
Divide it.
So ignore this. How do I turn the number 1 into a fraction?
Miss, you put a 2 under it.
Not a 2.
1 over 1.
I want to put it over 1. Any whole number is going to be over 1. Remember here? Any whole number can be written over 1. No matter what the whole number is. Whether it's 17 million, it's going to be over 1. If you want to turn any whole number into a fraction. Now, can I multiply?
Yes.
Yes, I can. So, 2 times 1 is?
2.
3 times 1 is? There we go. Happy days. Alright, let's do it again. Over here. I can't multiply these ones yet. Why not? Awesome. It doesn't have a denominator. This isn't a fraction yet. Sorry guys, I do realise it is difficult to pay attention to someone yammering at you for 2 hours, and I do apologise for that. But I just want to make sure that you have an understanding of all the points that you need to know. I'm summarising the 8 weeks on fractions that we did into 2 hours. So I'm sorry that you've had to just sit there and listen. That's not the way I like to run things,
Miss, why are you helping us?
because that's my job and I want you to do well.
Miss, but like
But now,
we have to pay attention in our 8 weeks of learning.
yes, but if you haven't, that's what today is for. But please just pay attention. We've only got a little bit more to go. All right.
I love math.
What can I turn this 4? How can I turn this 4 into a fraction? Shaka? Awesome. I'm going to put it over 1. Great. Now can I multiply them?
Yes.
Yes. How can I multiply these 2 fractions? Awesome. I'm going to multiply my numerators. 1 times 4 is 4. 5 times 1 is
5.
There we go. Happy days. Now let's do our next one. How do I turn this 7 into a fraction? Thank you for your enthusiasm. I'm very excited. But someone else who hasn't answered a question yet. Marina, how do I turn this? Oh, what was your hand up?
7 over 1.
Awesome. Now can I multiply these? Yes. 3 times 7 is 1. And then 4 times 1 is 4. I feel like Dora the Explorer answering my own questions. Tommy, how do I turn this 3 into a fraction?
4 3 under 3.
Ooh. This 1 under 1. Awesome.
If it's 12 over 7.
Awesome. Great. Happy days. Any questions about that?